All right, everyone, good afternoon. I see my clock has just ticked over to 1 o'clock, so that means we are going to go ahead and get started with our show today. So to introduce myself, my name is Andrew Bundus. I am one of the planetarium educators at the Liberty Science Center in Jersey City, New Jersey. And normally I'd be speaking to you from the largest planetarium in the Western Hemisphere, but today I am speaking with you from my living room, my kitchen, kind of the same room here. I'm very excited to be here today to talk with you about the June night sky. So we'll be talking a bit about some stars you can look for during June, some constellations, some planets, as well as some things that are up there in the sky that you might not be able to see with just your eyes, but with telescopes we can find and use them to learn more about the universe. Now, a few quick things before we do begin. First of all, we do encourage you to ask us questions during the presentation today. If you have questions, you can write them directly into the comments section. I'll be keeping my eye on it during the show, and we'll try to answer as many questions as I can during the show. I'll also be around after the show to answer many more of your questions. We also do have my colleague Mike, who is in the comments, who will be typing out some answers to your questions as well. So, with all of that said, let's go ahead and jump right in. We're going to be getting started with our show, looking at the June night sky. So, here we are looking at the sky as it will look on Monday, June 1st at 10:30 in the evening. This is about 2 hours after the sun has gone down. And this is what we're looking at, a really great simulation of what you'll be able to see in the night sky, assuming you live really anywhere in the northern hemisphere. I saw a few joining us over from Europe in Switzerland. You'll be able to see these exact same things. For anyone viewing this from the west coast of the US, Hawaii, you'll be able to see these exact same things in the sky. Now, the first thing I like to do every time I go outside to look at the stars is to first figure out kind of the directions, kind of get our bearings as to where we're looking in the sky. To do that, we're going to look for a group of 7 stars that we call the Big Dipper. So you may have seen the Big Dipper before, which is wonderful. Maybe you've never seen it. That's fine too. But I'm going to give you a few moments to look around up in the sky and see if you can find the Big Dipper. If you've never seen it before, the Big Dipper is made up of 7 bright stars that kind of make the shape of like a spoon or a saucepan. So I'll give you a few moments, look around up there, see if you can find that Big Dipper. If you're having a hard time looking for it, which is very understandable, there's a lot of stars we can see right now. The Big Dipper is located up here toward the top section of our view here. The Big Dipper, using our imaginations, we can draw these stars together into the shape of a great big spoon. This is what we know as the Big Dipper. Now, we use the Big Dipper to help us find our directions, kind of get our bearings in the sky. So we're going to use the 2 stars here at the very, very end of the bowl of that Big Dipper. We're going to draw a line through them, starting in the base, moving up toward the top. We're going to draw a line. If you want to follow the line I'm about to draw with your finger, or just use your imagination, you're of course more than welcome to do that. We're going to draw a line starting from here, down to here. Keep that line going down until we meet this star right here. Now, if you know the name of this star, you can let me know in the comments section. It's a very, very famous star that I'm sure many of you have heard of before. It's the main star that we use to find our directions. It is, as I'm seeing a lot of you mention, this is the North Star. Now, the North Star is really important because it always points us to the north. It never moves in the sky. It stays right there, always, always, always pointing us toward the north. So once you've found the North Star, we can draw this big red N in our simulated night sky. You don't have this in the real sky, unfortunately. It would be very useful if you did, but we can help us out here in our simulation of the night sky. So we're looking toward the north. The North Star sits right above the direction north. It's also a part of another shape in the sky you may have heard of before called the Little Dipper, which we can see right here. with the North Star making up the end of the handle, a few more stars making up kind of the bowl part of the Little Dipper. Now, these are two shapes that you may have seen before, and a couple shapes that are usually pretty easy to find because they are visible all year round. But it turns out these two shapes, these two dippers, are not constellations. They're a different kind of shape in the sky that we call an asterism, which is just a fancy word that means a shape that we draw in the sky with stars. Now, even though they are not constellations, they are pieces of constellations. The Big Dipper is a part of a constellation that looks a bit something like this. This is the constellation called Ursa Major, the Big Bear. And we can see right inside of it those 7 stars that make up the Big Dipper, kind of make up the back and the tail of this constellation, Ursa Major. Now, the Little Dipper is a part of its own constellation too, a smaller bear in the sky known as Ursa Minor. He looks a bit something like this. So these are our first 2 constellations we can find in our June night sky. And they're really great to look for during June because they're nice and high up in the sky. But you can see these 2 constellations all year round if you're in the northern hemisphere. You can see them all the time, which makes them really great things to keep an eye out for. But when I find these 2 constellations, especially Ursa Major, one of my favorites, there's an object, I'm going to draw a red circle around it here, that's kind of beneath the tail of Ursa Major. Where I've drawn this red circle here is one of my favorite objects in the universe. Now, you can't see it with your eyes. If you have a telescope at home, you can point it over in this direction, and what you'll find is a galaxy called the Whirlpool Galaxy. Now, when I look at it in my telescope from home, it looks pretty beautiful. But thankfully, astronomers can use telescopes better than the one that I have at home. This is the Whirlpool Galaxy, as seen by the Hubble Space Telescope. So because this is a galaxy, right, that means it's home to millions, billions even, of stars. The galaxy is made up of a couple main features. The center here, this bright spot, is the core, the very center of that galaxy. A couple of spiral arms moving away from it. You can probably see how it got its name, the Whirlpool Galaxy. But my favorite part about the Whirlpool Galaxy is actually this big fuzzy blob of stars over here on the right. This is, it turns out, a whole nother galaxy. This is a different galaxy altogether. It's named NGC 5195. And this galaxy is the Whirlpool Galaxy's companion. They've been colliding with each other for about the last 500 million years at least. Right now, they're kind of passing through each other. They've been doing that for 500 million years. And the gravity from the companion galaxy has really stretched out those spiral arms of the Whirlpool Galaxy. You can see one of these spiral arms getting stretched out over here, up in the top right. You also may have noticed, though, in the Whirlpool Galaxy, all of these kind of reddish, big fuzzy blobs, right? We see them all over the place. And I just saw a really, really great question. Anupa asked a really great question about whether there's a black hole in the center. Yes, there is a black hole right here in the center of the Whirlpool Galaxy. A pretty big one, too, about 1 million times the mass of the sun. But all of these reddish pink blobs of gas here, those are all places in this galaxy where stars are being born today. As we speak, stars in those galaxies are being born. So how exactly does that happen? How are stars born? Well, whether you're a star in the Whirlpool Galaxy or in the Milky Way, or if you're the sun, all stars begin their lives in exactly the same way. That's what we're seeing here. Stars begin their lives as clouds of gas, right? All stars begin as clouds of gas. Now, over the course of about 5 to 10, even 20 million years, the cloud of gas begins to shrink down and get smaller, and it gets smaller, and it gets smaller, which we're seeing happening here. As that happens, the cloud of gas gets hotter, And it gets hotter and hotter and hotter and hotter and hotter. Eventually, it gets so small and so hot that it turns into a star. Nuclear fusion begins. It lets out a great big flash of light, letting us know that there's a star here now. And at this point, a star has been born. So stars begin their lives as big clouds of gas. Now, I can hear a lot of you thinking, well, if that's where stars come from, where do planets come from, right? It turns out planets form in pretty much the same way. Any gas, dust, rocks that's left behind from this star being born will turn into planets, potentially, right? These little pieces of gas and dust and rocks will continue to shrink down even more. They'll form into planets. And we see in this solar system, we see 4 planets here at the center, 2 planets, 2 bigger gas giant planets here around the outside. And that's how every star in the universe begins its life. So as we look out into the night sky, like we can see here, man, think about that for a moment. Every one of these stars, these bright spots of light so far away, used to be a cloud of gas. It's a really, really cool thing to think about. And I see a really, really great question about how long does that process take? So for a star to go through that process from a cloud of gas down to it being a star, it can take anywhere from 5 million years up to like 50 million years, but it's a really slow, really, really slow process. So it takes at least 5, but usually more like 10 or 20 million years for a star to go from a cloud of gas to being a star. It's pretty cool. Now, this is the northern sky. This is what it'll look like pretty much all June long. We've got the Big Dipper, Ursa Major, the Little Dipper, and Ursa Minor. But let's spin ourselves around to a different part of the sky. We're going to move ourselves around to the eastern part of our sky, and we're going to look for my favorite 3 stars to find during the summer. So my 3 favorite stars to find during the summer make the shape of a big triangle. I'm going to give you a moment to look in the sky for a triangle. So that's 3 stars that are all very bright, and they're kind of low in the sky here on June 1st. But 3 bright stars and a triangle. I'll give you all a moment to see if you can find that triangle. And while I'm giving you that time, let me answer a few questions. So, I want to know, how big are stars? That's a really, really good question. So stars are really, really big. The sun, for example, is so big that we could fit the Earth inside of it over 1 million times. Some stars are even bigger than that. Some stars are smaller than that. But stars are way bigger than the Earth. All stars are. And so why is there this, I see another question, but why is there this letter E in the sky? It's a really, really great question. This letter E is marking the direction east for us. Okay. And right above this letter E, we can find one of the points of the summer triangle. So if you found these 3 stars, that's wonderful. If you weren't able to find them, that's okay too. Now you'll know exactly where to look in your night sky to find them. So those 3 stars make up the shape of the summer triangle. Those 3 bright stars all have names. They are Deneb, Vega, and Altair. So Deneb, Vega, and Altair. Those are the 3 stars that make up the summer triangle. Okay. Now, each of those 3 stars is important not only because it's a part of the triangle and they're bright, but they're all a part of their own constellation. So we're going to draw these constellations together using like little stick figures. So the first constellation we'll draw is this one here, with that bright star Deneb being right here at right over here on kind of the left side of this constellation. So looking at this shape, this stick figure, I want you to take a moment and use your imagination. What does this look like to you? And once you've thought of an answer, you can let us know in the comments section. I'm always very curious to see what we see in this group of stars. And I guess it only makes sense for me to go first, right? When I look at this group of stars, this constellation, I always see the shape of a bow and arrow. That's what I always see. Or maybe someone actually knows what constellation this is. Let's see. So I'm seeing a few answers coming in. I'm seeing Joanne mentioning this looks like a crane. Carla mentioning a bird. Teresa agrees with me and sees a bow and arrow. Hope also sees a bird. That's wonderful. Looks like a bird in flight. Yeah. So it turns out, those of you saying this looks like a bird, you would have agreed with the ancient Greeks hundreds of years ago. When they looked up at this group of stars, that's indeed what they saw. They saw this as the shape of a great big swan by the name of Cygnus. So this is the shape, the name of the official constellation. But I encourage you, when you go outside to look at stars, draw your own shapes with them. Use your imagination. Find your own shapes and tell your own stories with the stars. But this one, to astronomers and to the ancient Greeks, is the constellation Cygnus the Swan. Okay, so down below and to the right of Cygnus the Swan, we find this constellation here, with the bright star Altair making up this bright star here. Now think for a moment what this shape looks like to you. It looks to me kind of like a kite, almost, or a plane. A while ago, though, someone told me this looked to them like the top of a graduation cap. How they have those like very stiff squares on top. Now I can't say anything else. That's what I see here now too is the top of a graduation cap. Looks kind of like a kite, like a paper airplane maybe. Okay. It turns out the ancient Greeks in this part of the sky, they saw in this shape, they saw another bird. This bird is named Aquila or Aquila the Eagle. So Aquila the Eagle, we're seeing drawn here together with a person, right? That's because in ancient Greek mythology, they told stories about this eagle being almost like a taxi service, almost. She would carry people from the earth up into the heavens to speak with or to serve the gods. So that's where we see Aquila the Eagle. But again, we encourage you to use your own imaginations when you find shapes like this in the sky. The third and final of our summer triangle constellations is my favorite of the three, because it is without a doubt the hardest one to guess. So what does this shape look like to you? What does this look like to you? Looks like just kind of a triangle, kind of taped to the top of a rectangle. That's what I see up here. Maybe it looks like a fish, maybe? Maybe a necktie? Yeah. I can see a tie. I can see a fish. Ah, like a necklace, maybe. Melanie says this looks kind of like a necklace. Okay, okay. I can see that. I can see a necklace. Yeah, so it seems like the answer I'm seeing the most, maybe also like a kite, but I'm seeing tie and fish quite a bit. Turns out the ancient Greeks looked up here and they saw this not as a tie or a kite or a fish. They saw this as the shape of a harp. This constellation is named Lyra. This is Lyra the harp. Now, every time I look at this group of stars, I think the same thing. How in the world do you see this as a kite? Well, just like we do today, the ancient Greeks really were able to use their imaginations and saw this as the shape of a harp. It was really cool. So those are the three main constellations you're going to find in this eastern part of the sky all throughout June. We've got Cygnus the Swan, we've got Lyra the Harp, we've got Aquila the Eagle. But inside of Lyra, inside of this harp here, I'm going to point out another really cool object that is located here that you can't quite see with your eyes. A telescope. And this is, in my opinion, the most beautiful object in the universe. It's called the Ring Nebula. Looking at it through a really nice telescope, it looks like this. Beautiful. This is the Ring Nebula. The Ring Nebula is, just look at that. Spectacular. We see a lot going on here. At the center of this ring is this little white spot. That's actually a very old star. We'll talk about that more in just a moment. But all these gorgeous colors, this blue and green, yellow and red, that's all gas being lit up by this star. So the Ring Nebula is a type of object called a planetary nebula. And these form from stars. So the Ring Nebula actually began its life as a star. It's pretty cool to think about. Over time, though, it changed into that beautiful ring shape that we see now today. So let's take a look. We're gonna hop in our time machine, go back in time, and watch how the Ring Nebula formed. And we're gonna also go back in space. We're going about 2,500 light years away. So before the Ring Nebula was the Ring Nebula, it was a star that looked something like this, right? It was a star about the same size, about the same mass as the sun. And a star like this, or like any star in the universe, all stars work in pretty much the same way. We're going to kind of peel the top off of this star and look inside and talk a bit about how stars work. So inside of a star, there are two main things going on. Stars are made up of nothing but gas, and there's two main forces that are acting inside of this star. The first force we're representing by these green arrows pushing outward. That is the force of fusion. So nuclear fusion is what powers a star. That happens only in the core of this star. Right now, it's fusing hydrogen into helium gas. That's what's happening in the core of this star. It gets really, really hot, like 15 million degrees Fahrenheit. All this heat pushes out. So the force of fusion is trying to push this star apart. But this star is really massive, about the same mass as our sun. And so gravity, represented by these red arrows, is trying to make this star collapse and fall in on itself. So inside of a star, you've got gravity and fusion that are kind of working against each other. And for most of a star's life, they balance each other out almost perfectly. The force of gravity is equal to the force from fusion pushing outward. And so a star stays nice and stable. But eventually, this star is going to run out of its hydrogen. It's going to run out of its fuel. And we need to move away from the star here to watch what's going to happen to it next. Once this star runs out of hydrogen, it's going to start to collapse, right? There's no more force going out. Gravity takes over for a little bit. The star begins to collapse. But then it heats up. It begins to fuse heavier elements like helium. When that happens, there's more force pushing outwards. That makes the star get bigger. And it gets bigger and bigger, over 100 times its original size. It also changes color and turns into a red giant. The star then is going to live like this for 10, 20, 30, maybe even 100 million years. It's going to get bigger and smaller as it goes through its process. But then it's going to run out of its helium fuel. When that happens, the star no longer has forces pushing outward, and it begins to collapse. It loses the outer layers of that star. The inside of the star is going to collapse and turn into a white dwarf. That's that little white spot that we're seeing here. This is called a white dwarf, what's left over from the core of the star. And those outer layers, they are so far away from the rest of the mass of the star, they're not being held together by gravity anymore. They begin to expand away into space. So when we look at the Ring Nebula, what we're seeing here, that little white dot at the center, is what's left of the star. The beautiful colors of gas, that used to be the outside of the star. That's now expanding away into space, which is really, really cool to think about, right? So that happened to the Ring Nebula about 15, 20, maybe even 30,000 years ago. and we see it now today, which is pretty spectacular. So once again, over here in this eastern part of the sky, the easiest stars to find are going to be these three that make up the summer triangle. We'll bring up their names once again. We've got Deneb, we've got Vega, and we've got Altair. So those are three stars. You can find them all throughout the month of June here in the eastern part of the sky. But what about planets, right? My favorite thing to find in the night sky is planets. I love finding planets in the sky. It turns out in early June, we're still looking now at June 1st, you can't find any planets at 10:30 at night. You need to stay up a little bit later than that, or wake up earlier than that to find planets. But my bedtime is at 10:30. I don't like to stay up much past that. Thankfully, I'm in luck. And if you don't like staying up too late, you're in luck too. As June goes by, we'll be able to see a couple of planets rising earlier on in the evening. So we're going to move forward through time here and see how the sky is going to change throughout the month. So we're going one day at a time, we're now on June 6th, 7th. We'll notice the stars in the sky. We're still looking at 10:30. We notice the summer triangle is going to get higher and higher up in the sky. And beginning on the 15th, the 16th of June, we're going to start to see two very bright points of light beginning to rise over in this part of the sky. So kind of low in the sky toward the east. We start to see two bright points of light rising above the horizon. We're looking here at the sky on June 30th. So the two bright dots of light right here, this one's brighter, this one's a little bit fainter, close to each other, those are both planets. So those are both planets. The brighter of the two is the largest planet in the solar system, the planet Jupiter. And Jupiter is going to be the brightest thing you're going to see in this part of the sky, other than the moon if it happens to be over here. Looking at Jupiter through a telescope, though, we can see some of Jupiter's features. We can see its stripes. From this angle, it always looks kind of like a big hamburger to me, almost. But we can also see around Jupiter a couple of dots, very bright dots. With a good pair of binoculars or a telescope, if you look at Jupiter, you'll see 1, 2, 3, or 4 bright dots that are kind of moving around Jupiter. Those are the 4 largest moons of Jupiter. Those are the Galilean moons that were first seen by the astronomer Galileo way back hundreds of years ago. So if you've got a good pair of binoculars or a telescope at home, you can point them at Jupiter. Right? You can point them at Jupiter and see some of Jupiter's moons. But Jupiter is also really great to see with only your eyes. So if you don't have a telescope or a pair of binoculars, that's fine. That's fine. You can still see Jupiter with your eyes. It's really cool. The other planet in this part of the sky, down and to the left from Jupiter, is the beautiful ringed planet Saturn. So Saturn here is not quite as large as Jupiter, and it's further away from us, so it doesn't look quite as bright. But with a good telescope pointing it over at Saturn, you can see Saturn's rings. And if you ever have a chance to look at Saturn through a telescope, it is spectacular. You won't even believe what you're seeing. It's so cool to do. So if you've got a chance to do it at any point in time, I recommend taking the opportunity to look at Saturn through a telescope. We can see with a good one the rings of Saturn. With a really good one, we can see some of the features of Saturn. We can see some of its striped features as well. And in a few weeks, if you want to learn more about Jupiter and Saturn, we're going to be doing a show that talks pretty much only about Jupiter and Saturn. So we'll talk more about those two planets in a future episode of Planetarium Online. So that's the eastern sky during June, right? We can find the summer triangle. We can find those two planets, Jupiter and Saturn. Later on, if you wait a little bit later in the evening, you'll be able to see Mars as well. But at 10:30, Jupiter and Saturn are nice and visible once we get into the later part of June. But I want to spin ourselves around. We're going to do one more rotation here, and we're going to face now toward the south. so to the southern part of the sky. And in this part of the sky, we can still see Jupiter, we can still see Saturn. Now, if you're lucky enough to live in a place without very much light pollution, so without many lights around you, if you live far away from cities, you'll be able to see during the summertime the Milky Way Galaxy. That's this huge big band of light here. The Milky Way is the galaxy that we live in. It's our home galaxy, and we can see it with our eyes, but only if you are someplace with really, really dark night skies. But even if you aren't somewhere with really dark night skies, let me point out a couple things to look for to help you find your way at least toward where the Milky Way is going to be in the sky and where the center of the Milky Way is going to be in the sky. So over here toward the southern part of our sky, toward the southeast, just to the right of Jupiter and Saturn, we can find this constellation here, marked most easily by this center group of stars, which looks kind of like a teapot to me. Right? We've got the handle, we've got the top, we've got the spout of our teapot here. If you can find this teapot shape of stars looking above this little spout here, this is the center of the Milky Way Galaxy. So this is the center of the Milky Way, which is pretty cool. Now, if you remember, when we looked at the Whirlpool Galaxy, I said that the Whirlpool Galaxy at its center has a black hole. It turns out we also have a black hole at the center of our Milky Way, 26,000 light years away right in this part of the sky. Very far from us, we don't need to worry about it, but it is there. Now, what we're going to do is actually take a trip now to the center of the Milky Way Galaxy, and we'll talk about how we know that there is a black hole there. So let's hop into our spaceship here. We're going to travel to the very, very center of the Milky Way Galaxy. Here we are at the center. What we're looking at now, a lot of red kind of ovals, these red lines. Those red lines represent the orbits of stars. Right? These are the orbits of stars. These are the paths that these stars are taking as they go through time. And over the last few decades, we've watched these stars very, very closely. Very, very closely. And we noticed that they're all orbiting around the same part of space. They're all orbiting around where we've drawn this little blue circle. They're all orbiting around that. And by measuring how fast these stars are going, some of these stars are moving at like 11 million miles per hour. Really, really fast. We know that they are orbiting around something that has a mass of over 4 million times the mass of the sun. But we don't see it there, right? We don't see it there. But we know it's there because of its mass. So we conclude, based on those two things, that there's a black hole right here at the center of the Milky Way Galaxy by watching these stars make their orbits. That's pretty cool, right? We can observe the center of the galaxy, observe those stars, and learn more about it. We learn there's a black hole there. Now, do we need to be worried about that black hole? No, thankfully not. It is 26,000 light years away. It is so incredibly far away from us, it really doesn't affect us at all. We don't need to worry about it, but it is there. And if you have a really, really dark night sky at home, which I hope some of you do, you can find where the center of the galaxy is, where that black hole is, right over here in this part of the Milky Way. Or if you use our little teapot shape here as a guide, right above the spout, right here, if you can find this part of the sky, right there is a black hole that weighs about 4.5 million times the mass of the sun. the most massive object in the Milky Way Galaxy. We've shown you now a few things to keep your eyes out for in the sky. In the south, we can find this constellation. I look at it as a teapot, but it is a constellation called Sagittarius, the Centaur Archer. You can see him here pretty well. The Milky Way Galaxy is beautiful to see during June and July and August as well, is the best time to see it. We can also see a couple planets, right? Right over to the left of our good friend Sagittarius, we find Saturn and we find Jupiter. We've seen some other constellations too. Looking over toward the eastern part of the sky, once again, we saw them all throughout June. You'll be able to find these 3 stars that make up the summer triangle. And as June goes along, it'll get higher and higher and higher up into the sky. And every single night of the year, assuming it's clear, looking around toward the northern part of the sky, always find our good friends, the Big and Little Dippers. As constellations, though, they are known as Ursa Major and Ursa Minor. So I hope that you all can take some time during June to step outside on a nice, clear, warm night and take a look at some of these wonderful things to keep your eyes out in the nighttime sky. But this does bring us to the end of kind of the main presentation part of our show. We will be sticking around for another at least 10 minutes to answer more of your questions. I know you all have a lot of questions, so start thinking about what questions you have, typing them into the comments. But before we do get started with our question and answer section, I do want to take a moment to thank you all for joining us today for Planetarium Online. In this very strange time that we're living in right now, I've found it really wonderful to spend some time every Thursday at 1 o'clock to talk with you guys about the things I am passionate about. Stars and galaxies and planets, black holes. I love to talk about it. And it's my goal and the mission of Liberty Science Center to inspire the next generation of scientists and engineers. So anyone out there who's thinking about going into a career like that in the future, becoming a doctor, a scientist, an astronomer, keep on challenging yourself. It's a very rewarding, a very fun field to study, and it's my goal and the Liberty Science Center's mission to help inspire you to do that. So keep working hard. You guys represent a very bright future for all of us. Now, to do that as a nonprofit organization, Liberty Science Center doesn't rely on donations of any amount to help us continue to present programs like this and all of our other STEM programs. You may have seen some of our wonderful live from programs or our animal updates that we run here on our Facebook page. So a special thanks goes out to any of our members and supporters so far. You guys are helping to keep us going, and we really, really appreciate it. If you're able to, you can support us always by visiting lsc.org/donate at any time. We do appreciate all of your support to help us continue to inspire the next generation of scientists and engineers. So, with all of that said, let's go ahead and answer some questions. So I see a great question about what is the name of the black hole at the center of the Milky Way Galaxy. So the black hole at the center of the Milky Way Galaxy is named Sagittarius A star. That black hole is called Sagittarius A star. That's the name of that black hole, Sagittarius A star. Belma wants to know, will Saturn and Jupiter collide with each other? That's a really, really good question, right? Because when we look at Jupiter and Saturn here in our nighttime sky, they look very, very close together, right? Here's Jupiter, here's Saturn. Okay, so they look very close together, but they're not going to collide. They only look close together with our eyes. In reality, these two planets are a few 100 million miles apart. Saturn is much further from us than Jupiter, so they're never going to collide. It's a really, really good question, because it does look like it, looking at them here in our nighttime sky. Let's see. So, Dahlia from New Jersey wants to know, how does the gas heat up so much to form a star? That is such a good question. Thank you for asking it. Let's take one more look back at our uh, little animation here of how the star is born. So there's a couple reasons why this cloud of gas heats up. Part of it is the force of gravity that's being exerted, it's being pulled on inside of this cloud of gas, uh, uh, transfers heat to this cloud. Also, part of it is friction. If anyone's taken a physics class before, you may have heard of the term potential energy, the conservation of potential energy. As this cloud of gas shrinks down, its potential energy is converted into heat energy. Over time, it causes it to get so hot that it turns into a star. That's a really, really good question. Let's see. So I also see here a really, really great question from my mom. So my mom wants to know, where is the best place to look at the June night sky? It's a great question, Mom. Thank you for asking it. Really anywhere where you have a dark night sky is the best place to be. If you go somewhere that is like up in the mountains, away from the stars, or sorry, away from bright lights of the cities. So the best places to view the night sky are away from the city lights. So away from the lights of the cities as far as you can get, find a very, very nice dark night sky. Okay, so Kai wants to know, where is Gemini in the June sky? So Kai, Gemini is not something we can see in the June sky really at all. Right now, Gemini is actually kind of behind the sun. If you want to see Gemini, your best thing to do is to wait until the winter time. In the winter time, that's the best time to see Gemini, is during the winter season. Not something we can see very well during June or during the summer. Very well. So, Krishna wants to know, how many stars are there in the sky? That is such a good question. So with your eyes in a really dark location away from lights of the city, you can see about 4,000 stars. If you live someplace with lights, like where I am here in Jersey City in New Jersey, a lot of lights around me, close to New York City, I can't really see that many stars in my sky. I can see maybe 50 or 100 on a good night. But the most you'll ever be able to see with your eyes is about 5,000, 4,000. Okay. So I'm seeing a few questions here about how black holes form. So I see Sonia is answering, or is asking that question. I've seen a few more questions like that as well. So how does a black hole form? So a black hole forms in a kind of the same way that we watch the Ring Nebula form, only from a way bigger star. So for a star that's like 15 times the mass of the sun, it can form a black hole, right? It'll go through a similar process. It'll grow into a red giant, but then when it runs out of fuel, it has so much mass that when it collapses, it's going to turn into a black hole. All that mass gets crammed into one single point in space. It's really, really cool. That's really, really cool. So we got another question about, where do the stars go in the morning or in the daytime? It's a really, really good question. So in the daytime, the stars are still there in the sky. They don't really go anywhere. But during the daytime, the sun is so bright that we can't see anything else. So during the daytime, like right now, if I were able to go outside and turn off the sun, we'd be able to see stars. But during the daytime, we can't see them because that's when the sun is in the sky. And the sun is so bright that we can't see anything else. So during the daytime, the stars are there, they're just overpowered by the brightness of the sun. So thank you all so much for question. That's okay. So I see a really, really great question here about why the orbits of the stars orbiting around the Milky Way. So why are the stars orbiting around the center of the Milky Way not in the same plane? So if we look back at that animation here briefly, I'll show you kind of what I mean. So there really isn't any pattern to how these stars, they're just kind of this big web around them. When we look at like the orbits of the planets in the solar system, they form kind of one plane. So it's really so why don't these stars do the same thing? It's a great question. So it turns out most of these stars were not born here, right? The planets orbit in the same plane because they were all formed from the same cloud of gas at the same time, around the same time. These stars, though, were all born in different places, and the gravity of this black hole captured them. So that means they're going every which way, right? They're all over the place because they didn't form from the same cloud of gas. A really, really great question. Very observant to be able to notice how kind of crazy and chaotic these orbits are. Let's see. So I got a question about how do I recommend star hopping to the Whirlpool Galaxy with a telescope? That's a really, really good question. So what's the best way to actually find the Whirlpool Galaxy using a telescope? So even though I spend a lot of time looking through telescopes, finding things like the Whirlpool Galaxy, it's really hard to do sometimes. But we can actually use the Big Dipper as kind of a guide, help us out. So if we find the handle of the Big Dipper, let me go ahead and move over here to our view of the night sky. If we use the handle of the Big Dipper as a guide, so like right around now, if you can find this star at the very end of the handle here, you'll want to then pan your telescope over a little bit toward the west. That'll be during most of June, to find the Whirlpool Galaxy through your telescope. It can be really hard to do sometimes because you do need a pretty dark sky and a big telescope to be able to see. All right, so many questions. I love answering all of your questions. We have time for maybe just a few more. Let's see. So Kathy wants to know, and I've seen a few other questions about this as well. Do stars ever die out? It's a great question. So all stars eventually will die out. Eventually. Most stars, though, live for billions of years. It takes a really, really long time. But all of these stars are being powered by fusion, and they're using up fuel to do that. Eventually, just like a campfire runs out of wood to keep it burning, stars eventually too will run out of fuel to keep them going. But it does take a really long time, right? It takes billions of years for most stars to run out of their fuel. When some stars run out of fuel, really big ones, they explode. Some smaller stars, like the one we saw form the Ring Nebula, when that star reached the end of its life, it just kind of slowly expanded and collapsed slowly. So big stars explode, smaller stars are a bit more calm. Really great question. Let's see. So we're going to answer maybe two more questions here before we do run out of time. So Avery wants to know, how fast do stars travel, and do they crash into other stars? A really, really good question. So most stars move very, very slowly. We don't see them moving from the Earth very well, right? You go outside tonight, you'll see stars. The next night, you won't really see them moving through space very much. They move pretty slowly. Stars, though, at the center of the Milky Way, like we saw a moment ago, those stars can move at like 10, 11 million miles per hour. Other stars move at more like 10 or 20,000 miles per hour as they kind of circle around the Milky Way. But those stars don't really ever collide with each other. It does happen very rarely, but it is very rare for stars to actually collide. It's a really, really great question. So one more question. So I'm seeing a lot of questions that I've seen so far about what's going to happen to the sun, right? I mentioned a moment ago that the Ring Nebula is about the same mass as the sun, or at least the star that formed it was the same mass as the sun. It turns out in about 5 to 6 billion years, the sun will go through that exact same process. The sun is going to run out of its fuel. The sun is going to start to get bigger, and it will turn into a big cloud of gas like the Ring Nebula. But that won't happen for another 5 billion years. And by then, humans will be able to move away from the sun, hopefully. We don't need to worry about the sun changing too much. But with that, I do want to thank you all so much for joining us today. Thank you for, as always, for all of your wonderful questions. This is always my favorite part of my week, being able to hang out here with you all and answer your questions and engage with you. So thank you for sticking around today. We'll be back, though, next week, Thursday at 1 o'clock. We'll be talking all about human space flight to the moon. So please join us again next week. Next week, Thursday at 1 o'clock p.m., we'll be talking all about our goals of taking humans back to the moon. But thank you all once again for joining us today. Have a wonderful rest of your afternoon and a great rest of your day. Take care, everyone. Thank you.